All right, perfect. If you guys can hear me, just punch in yes via chat. Just say yes or okay if I am audible and clear. And if you can see my screen, the title, my name, and my email ID, just say yes or no via chat. All right, perfect. Thank you so much. A very good morning and welcome to today's webinar. My name is Abhilash and I will be your presenter for today. So before we get started, I'd like to thank you all for joining in. Thank you so much for your time and your patience. So yes, today's webinar is about securing hybrid identities with two-factor authentication and advanced password controls, right? Now, the reason I picked this topic is because user logons and user passwords, they are the baseline, right? They are the first line of defense for any organization security. And if a malicious user can potentially gain access to your internal network, that's the end of things, right? Now, with that said, all the source links are embedded within the slides. You can find the source links at the bottom right corner. And if you have any questions, please keep them coming via chat. And abhi@manageengine.com, that's my email ID right there. So if you have any questions or if you need any information, please drop in an email and I'll get in touch with you very soon. All right, perfect. So just a second. All right. So a quick look at today's agenda. We will have a look at today's attack landscape, right? This is the attack landscape of 2019, right? Because technology has evolved and so have attacks. Attacks have gotten sophisticated, they've gotten dangerous, and most importantly, they have gotten easy to perform, right? And especially with the cloud elements in the picture, the surface area for an attacker is now larger than ever, right? The number of loopholes, the number of probable entry points for an attacker is now larger than ever, right? And in the second part of today's webinar, I will be showing you a live simulation of a security attack. Now, the reason I will be showing you this is to prove a simple point that you needn't be a professional, right? You needn't be a hacker to conduct a full-blown attack. All you need is a little bit of internet, a computer, and some motive, right? And then we'll have a look at a few tips and techniques that we could employ to harden our security foundation. And finally, we will see how AD Self-Service Plus can be leveraged to solve all of these problems, right? And this is the attack landscape of 2019 because attackers have gotten sophisticated, they've gotten dangerous, and it's not like the olden times where attackers only used to target the top-notch celebrity companies, but the smaller thriving companies, right? They are even a better target these days, right? Because have a look, on April 15, 2019, Microsoft was subject to a data breach, right? And this breach basically happened where a hacker gained access to a support personnel's credentials, right? And the hacker could be in the network for a period of 6 months. Please note the time. The hacker was in the network for 6 months and Microsoft didn't have a clue, right? And the Verizon's 2019 report, the latest data breach report that came out, states that 56% breaches took longer to discover, right? 52% breaches involved hacking, involved using of user credentials to seep into the network, and 43% breaches involved the smaller business victims, right? The smaller thriving companies. And this is an accurate example of today's IT setup in organizations because it's just not Active Directory anymore. We are slowly tending towards these cloud hosted applications, right? Applications like Office 365, like Salesforce. The reason we are doing this is actually pretty simple. We have the need, we have the necessity to get that extra support, right? Get that extra push from these third-party providers so we can stay ahead of our competitors, so we can stand out in the big game, right? So we end up taking support from these third-party providers. And please note that for most of these cloud-hosted applications, the central point, right, for authentication and authorization is Active Directory. For example, Exchange, SharePoint, SQL databases, right? Active Directory does the authentication and authorization, right? Now, according to me, there are two pieces to the hybrid puzzle. Piece number one is the workload, right? Because we need to know which application handles the most workload and how is the workload distributed and how are the security parameters across these applications, right? The second piece of the hybrid puzzle is the user data, right? User data is the new cash, is the new commodity in today's IT industry. User data is the one thing that you will want to protect, right? Now, the idea I'm trying to put forth here with all of this information is we need a right mix. We need a right balance of security and control over our traditional in-house setup and our cloud-hosted applications, right? Now, granted that a hybrid IT infrastructure may be a go-to choice or maybe a perfect choice for most administrators, but it does come with its own set of limitations, right? So the first limitation is Windows domain single sign-on. Now this might sound very simple, but it affects all the users in your organization. Let me illustrate this using an example, right? This is a fine Monday morning and a user has logged onto his or her domain join system, right? And let's say the user has work across 4 to 5 cloud hosted applications. Now 4 to 5 is a very liberal number that I'm taking, right? Because organizations use at least 10 to 12 cloud hosted applications. Now, please take a second, put yourself in the end user shoes and think about how annoying and how frustrating this can get for your end users, right? Because they potentially need to remember 5 sets of usernames and 5 sets of passwords, right? And let's leave the user comfort part alone. Let's jump in to the user security part, right? When a user is forced to create passwords across multiple cloud hosted applications, he or she will set up weak passwords, right? Because these applications, they do not have a strong password policy. And I personally believe that the password creation guidelines, they are not good enough to create a strong password, right? The second challenge is your employees, they use a mix of cloud applications. For example, your sales user probably uses the Salesforce application. Your developers probably use HackerRank. Right now, it's the administrator's pain to sit back and set up single sign-on for different employees of an organization based on the job role, right? Based on the application they access, right? And the third problem is user security. Now, we have spent years and probably decades perfecting our on-prem infrastructure, and with the sudden introduction of these cloud-hosted applications, we might need an additional layer of security, right? For instance, two-factor authentication to verify if it is the legitimate user, right? But the problem here is most cloud applications, they don't even support two-factor authentication, right? And the second point comes into picture again where the admin has to sit back and figure out two-factor authentication for different users based on the applications they access, right? And two-factor authentication most commonly works for local logons. Users are on the move and they access their systems remotely day in and day out, right? If two-factor authentication is not supported for remote logons, this is not a secure process either, right? Now, a question that I have been asked and I found myself asking multiple times is whose responsibility is it to secure the hybrid setup, right? Because there are multiple actors involved. There is the administrator, there is the cloud provider, right? Who do we blame if something goes wrong? The answer to this question is joint hands, right? It's the administrator's responsibility to set up strong security policies, right? The administrator has to know which applications his or her users access, right? Because shadow IT is growing, and all it takes is just one naive user to take an important piece of information and just put it on the cloud application that the administrator is unaware of, right? And it's also the end user's responsibility. Now, the reason I'm saying this, because end users need to know how to treat their passwords, right? They need to know the basics of password security. They need to know how to construct strong passwords, right? And it's also the cloud provider's responsibility, because it's the cloud provider's job to secure his or her customer accounts, to secure his or her physical data centers. And it's joint hands, like I always say, that give us the security, that give us the control that we need, right? Now, time for the surprise part of the presentation. Now, I said that I will be performing a simulation of the security attack, right? Now, this attack is going to be focused on the Outlook Web Access Portal of an on-prem Exchange server. Now, the reason I chose the Outlook Web Access Portal is because mail, right? Users access mail day in, day out. The administrators, the end users, the CEOs, the users who are always on the move use mail as a basic form of communication, right? And if we could potentially attack a mailing server, we could read the sensitive data that has been passed inside the organization, right? And mainly the Outlook Web Access Portal, because any organization who use Exchange servers use Outlook Web Access. The reason is because Outlook Web Access comes free with the Exchange server, right? So let's go ahead and perform the attack. So this is my VM right here. All right, it's going to take a second. All right, so this is my VM, right? And let me quickly show you something. If I open up PowerShell, I'm just quickly going to show you what parameters are needed to run this attack, right? So I will quickly open up PowerShell right here. Okay, here we are. Just waiting on PowerShell to open up. And here we are, right? So this is PowerShell. Okay, it's still loading. Just give it 1 second. Just waiting on PowerShell to load, and perfect. So we are logged in as a user called James, right? Now the reason I'm showing you this is to prove a simple point, that you needn't be an administrator or have privileges even to perform an attack. Right now James is logged in to his domain join system, and let me quickly show you something, right? So if I copy this command, now this command is just a basic command that will find out the membership of the domain admin group, right? So once I hit enter, we'll just give it 1 second. Okay, it's querying Active Directory for the domain admin membership. And here we are, right? Please note that James is not a member of the domain admin group. This is a user with absolutely no privileges, right? So what I'm going to do now is quickly shift to the desktop, and let me show you 3 important things, right? The first thing is the mail sniper module. Right now, this module is what we're going to use to perform the attack, right? We can find this module on GitHub. I have left the link to it within the slide itself. And then this is a list of probable domain names, right? The end of an email gives you the domain name. The name of the organization is generally the domain name. And there are PowerShell modules and tools online that take in certain parameters that could potentially let you guess domain names, right? And finally, we have another text file, which is the potential list of usernames, friends that are working in that organization. A simple LinkedIn search could give you a list of connections, right? So with that said, we have 3 modules here and the mail sniper module as well. Let me quickly open up PowerShell and clear this up. So I will run a command called PowerShell.exe-exec and then bypass, right? Now, this command basically lets your end users or lets you as a user with no privilege run PowerShell scripts that are not digitally signed, right? That are not authorized by Microsoft. And please take into account that this command needs no privilege to be executed, right? So let me quickly import a module. So I will call it import module dot slash mail sniper, right? The module that I just showed you on the desktop dot ps1, right? And once the module is imported, let's go ahead and invoke domain harvest OWA. You guessed it, it's the Outlook Web Access Portal, right? And it's given the exchange hostname, which is WSM16-DC1, right? The host name of the on-prem exchange server. And finally, let's give in a list of domain names, the text file that I just showed you, right? So I will quickly specify the path right here. The path will be the same because it's on the desktop. And then let's call it domain list.txt, right? The name of the text file. And once I hit enter, what's going to happen is all the domain names in the text file are going to be run, and practically within seconds we have a valid domain name, right? That's WSM16.com. Now let's go ahead and invoke username harvest OWA, right? And the same command again, which is the exchange hostname, right? WSM16-DC1 and user list, right? Now the user list is the list of potential usernames that I just showed you. So just select the user list, which is C users, James, desktop, and user list dot txt, right? And finally, we will give in the domain name as well, the name that we just found to be valid right here, right? Which is WSM16.com. And once I hit enter, we can out this file to a text file that will contain a list of valid usernames in that domain. So let's just call that valid usernames.txt, right? And once I enter, we can see that the spray has started and it says that we have found potentially 0 valid usernames. Right now, please don't be alarmed because we need to go with the response time, right? So the lower the response time is, the user is actually valid. Now in this case, Tom is a valid user. Jerry is also a valid user, right? So if the response time is about higher than 100 or 200, then the user is not valid, right? Now that we have a list of probable usernames and the name of the domain, let's go ahead and invoke password spray, right? So that's invoke password spray, the same command again, right? Let's give in the exchange host name, which is WSM16-DC1, right? And now that we are unsure which user is actually valid, let's go ahead and import the same list again, right? So we will be performing a password spray attack on the user list. So that's C users James desktop user list dot txt, right? And the password that we will be using to perform the spray attack will be password at 123. Now this is a common password pattern that is used by most organizations, right? So we are going to try out this particular password on the list of usernames, right? So once I given that, let's specify the domain name again, which is WSM16.com. And once I hit enter, we can see that the spray has started, and this will probably take like a second or two for the spray to complete. But please note that Active Directory is trying to block the attack, right? It's trying to block the attack because the Internet Explorer right here is throwing an error, right? But please take into account that the script is still running in the background. Right here is the loading page. Right, the script is still running in the background, and we have already found 3 users who use the weak password pattern. Right, so let's just try closing this pop-up, and it will be popping up again and again because Active Directory is still trying to block the script. Right, so let me close the pop-up again. Close, close. Okay, I think this should be the last of it, and here we are. We have potentially found a list of usernames that use the weak password pattern, right? That have their passwords as password at 123. Now that we have a compromised user account, the username and his or her password, let's go ahead and invoke a global mail search, right? So what I will be doing now is I will run through all the inboxes in the organization and look for sensitive mailing information, right? So again, the exchange host name is WSM16DC1, and we will be using a new command here called the impersonation account. Right, now what this command does is it uses James's account to impersonate the administrator of the domain WSM16.com. Right, so impersonation account will be James, and let's go ahead and out this file. Right, so let's call this output CSV to, let's say, mailer data.csv. Right, and once I enter, we can see that the search has started and we have been prompted to enter credentials. Right, so let me give in Tom's credentials right here. Right, we could potentially use any user's credentials. So once I give in Tom's credentials and once I hit OK, we can see that it's establishing a PowerShell session to the server right there, and it will now potentially run through all the mailboxes in that particular domain. Right? So let's just wait a second, and we can see now James is being granted application impersonation rights, and that's the first mailbox. The second, the third, the fourth. Right? There are potentially 24 inboxes in the organization, and we are running through all of the inboxes to look for sensitive data. Right? The data being password, cred, and credentials. Right, now the results have been sent out to a CSV file. Now let me quickly show that to you. Here we are. This is the CSV file where the results have been exported to. Right, all of the information is neatly categorized for our reviewer. Now the sender is Luna. Received by Tom. The subject is credentials for CRM system. Right, and the body, hi Tom, please find your new login credentials, and here is the username and here is the password. Right now, the malicious user, or the attacker in this case, has access to an internal CRM system of the organization. Right? And this is how the attack panned out. We started off with basically no information, right? We didn't know the domain names. So we started guessing a list of probable domain names. And then we tried a list of probable usernames against the domain. And once we found a valid user, we performed a password spray attack. Right now, this attack is in such a way that no user account gets locked up. Right? And once we found a compromised username and password, we use those credentials to potentially get the entire mailing list of the organization. Right? So we went through each inbox in the organization and we pushed out the mail that have sensitive information. Information that includes details like passwords, creds, or usernames. Right? Now, the problem that caused this attack is not one, but actually two. Right? The first problem is the cloud applications used, they are not well protected. Right? We saw it, we performed the attack on the Outlook Web Access Portal of the on-prem Exchange server. Right? And the second problem is that the password we used, they are extremely weak. They are extremely vulnerable. Right? So the fix for problem one is we need to employ two-factor authentication. Right now, using usernames and passwords just won't cut it anymore, right? Because we saw it, we performed an attack on a common password pattern, and we could potentially get the entire mailing information within an organization, right? So what we need now is a secondary mode of validation, something that double checks the legitimacy of the user, right? Tip number two is we need something to centrally manage access, right? So what we need is a single screen, a single pane of glass from which all of the cloud applications in the organization can be managed, right? So access to these applications can be easily assigned or revoked from a single pane of glass, right? And tip number three is just disable PowerShell, right? Your QA engineers, your developers probably need PowerShell, but your sales users, your marketing users, your support people do not need PowerShell, right? So just disable PowerShell for your employees who do not need it. And if they need to access it, please set up authorized access, right? And tip number four is use a SIM solution. A SIM solution basically gives you details about who, what, and where of the attack. Right now, we do have an in-house SIM solution called the Event Log Analyzer. I will leave a link to it so you can test it out and play with it in your own environment, right? Now, AD Self-Service Plus can be used to solve these problems, right? So a quick recap on what AD Self-Service Plus is. It's a web-based end-user self-service solution. So using AD Self-Service Plus, your end users can potentially reset their own passwords, unlock their own accounts, and fill in their personal information like emails and phone numbers, right? Your administrators can use AD Self-Service Plus to set up single sign-on to all cloud applications that support SAML-based authentication, right? And AD Self-Service Plus also offers two-factor authentication that affects your local logons and your remote logons as well, right? Now let's go ahead and set up two-factor authentication with AD Self-Service Plus. So what we'll do is I will quickly take you to my browser here. This is my AD Self-Service Plus portal, right? So let me quickly log in as the administrator. All right, so once I log in as the admin, all we have to do is head into configuration, right? And then administrative tools, GNOME Linux, Windows Logon TFA, right? Now all we have to do is just check this box, right? And this would enable Windows Logon TFA. Please ensure that the SSL certificate is installed, right? Because we want this process to be secure, for which we will need the HTTPS protocol, right? And once this is enabled, head into self-service, policy configuration, and these are my policies configured right here, right? If I click on the advanced settings of a policy, we have something called login TFA, right? Now all you have to do is just click enable and select the required option. Right now, please take into account that policies can be applied to groups, to OUs, and to your individual users. Right? So once this is done, let me quickly show this to you in action. So this is how it would potentially work. Right? So when a user logs on to his or her domain join system, the AD Self-Service Plus portal will open up, and in this case, the two-factor authentication that we're using is a verification code, right? So the user would potentially receive a verification code on his or her email ID. And once the user enters the valid verification code, he or she is logged into AD Self-Service Plus, right? So that's one-time password entering, one-time authentication with two-factor authentication, and that's it. This secures access to your on-prem AD resources and your on-prem applications, right? Now you might ask me this question that what happens to my other applications, right? Applications like Office 365, like Zoho, like Salesforce, right? They have their own authentication mode. They have non-active directory authentication. So what happens to applications like these? And the problem that I mentioned earlier about users entering their passwords multiple times still stands, right? Because granted that we have secured access at the logon, the user still needs to enter passwords again and again to log into the cloud hosted applications, right? Now, in order to combat that, we will need single sign-on, right? So the idea here is to set up two-factor authentication at the logon screen and combine that with single sign-on, right? So when a user logs on to his or her domain joined system, right? So he or she enters the password once, goes through the two-factor authentication method, right? And that's it. The user will have seamless access to all of the cloud hosted applications, right? So a quick recap of what we saw till now. We saw how easy it is to perform an attack, right? We saw how easy a seemingly harmless employee in your organization could perform a full-blown attack, right? Now, in order to combat that, we set up two-factor authentication at the login screen, right? Now, this secures access to your on-prem resources and your on-prem applications where Active Directory does the authentication and authorization, right? Now, when it comes to applications that are not authenticated or authorized by Active Directory, we combine two-factor authentication plus single sign-on, right? So the end result here is one-time password, one-time two-factor authentication, and seamless access to all of the cloud hosted applications, right? So what we've essentially done here is we have pushed the logons across all of these cloud applications to one central point, right? Active Directory. So we made Active Directory logon the one central point of security. But the problem still stands. The reason I'm saying that is because the passwords that we use, they are weak, right? They are extremely vulnerable, right? So the fix for the second problem is we need to employ stronger passwords, right? Now, the reason I'm saying this is because the attack that I just showed you today is one form of an attack. A password attacks can come in many forms, right? Now, you might ask me this question, why do we need a stronger password policy? If we could potentially set up stronger parameters on the native Active Directory password policy, that would be good enough, wouldn't it? But the need for the stronger password policy is because Active Directory's password policy is very old, right? So a quick jump back into history. Active Directory's password policy came into picture with Windows 2000, right? That's more than a decade, more than 14 years of using the same 6 password settings. Please note that there hasn't been a single change. There hasn't been a single update, right? And the truth here is just because these settings have been around for so long, attackers have invented their formulated ways around these password policy settings. Right, now let me quickly show you something. This is my VM, and if I log into my DC here, right, so this is my DC. So let me quickly log into my DC. All right, so once I log in as the administrator, here we are. This is going to take a second. So let me quickly open up the ADUC tool, right? The Active Directory Users and Computers tool. Just waiting for this to load, and here we are. Okay. So once I open up the Active Directory Users and Computers tool, let me quickly show you something. Okay, so it has opened up, and let me reset the password for the user Luna. Right now, Luna is a user who has forgotten her password. So once I reset Luna's password, let me give in password at 123, right? Password at 123. And once I hit OK, we can see that the password has been reset, right? So let me do that again. Now Luna is very forgetful, so I need to reset her password again. So let me give in password at 123, right? Password at 123. Please take into account that Active Directory does not check the passwords that were used during reset, right? So you could potentially use a password for multiple users, how many ever times you want during reset, and Active Directory does not track that. Now this is just one example of how weak the Active Directory password policy is, right? And we perform the attack based on weak password patterns like password at 123, right? Now, Active Directory's password policy applies on your domain node, right? So your privileged users use the same 6 password settings. Right now, that's when Microsoft heard of problems and they came up with something called fine-grained password policies or password settings objects to be more precise. But the problem here is they still house the same old 6 settings, the settings that are a decade old, and they cannot be applied directly to your OU structure. Right now, I mentioned that password attacks can come in many forms. The most famous form of performing an attack is by using the hashes, right? So what happens is when a user logs on to his or her domain join system, two kinds of hashes are generated, right? The LAN manager hash and the NTLM hash. The LAN manager hash is stored in the SAM database of the LSA, and the NTLM hash is stored in the ntds.dit file, right? So what attackers do is they obtain these hashes somehow, right? There are tools offered by Microsoft, for example, ATDS.util and the NTDS audit tool that can be used to obtain these hashes. And the second step is to crack the password hashes. Tools like Kane Enable, like Mimikatz, like Metasploit can be used to crack the password hashes, right? And this is an example of pass the hash attack. Right, so what happens here is an attacker uses the stolen password credentials, stolen password hash, to perform an attack. Right, how this works is an attacker basically requests access to a file server. Right, now a user's password is never sent over the network. Right, so the attacker requests access to a file server sends back a challenge. Now a challenge is a 16-bit number, right? So what happens is the attacker encrypts the challenge using the stolen user's hash, right? And the attacker sends it back to the domain controller. Now, the domain controller decrypts the encrypted challenge using the hash stored in the ntds.dit file, right? And once the domain controller decrypts the challenge, it assumes that the attacker who is requesting access to the file server to be the victim user, right? And it gives access to the attacker thinking the victim user is actually requesting access, right? This is an example of how hashes can be exploited. Right now, a few tips that we could employ for stronger passwords. Tip number 1 is adopt the 8+4 rule, right? Use upper characters, lower characters, special characters and numbers, but please make sure that you mix and match them to create a secure pattern. Right now, password at 123 is a password that uses all of these characters, but the pattern is easily guessable, right? Second tip is adopt passphrases. Now this is one of my favorite and the most useful probably, because take passphrases that you could remember, right? For instance, the sun will rise again tomorrow. Pick a letter from each word, add in numbers and special characters, mix and match them to create strong passwords, right? And at the same time, they are extremely easy to remember, right? And tip number 3 is adopt MFA. Adopt MFA for any change password activity, right? Adopt two-factor authentication at the logon that will double check the user identity, right? And finally, set a number that will lock out a user, because most brute force attacks and most dictionary attacks are geared towards the lockout threshold, right? So if there is no lockout threshold that is set that will lock out a user after a set of invalid attempts, the number of opportunities for an attacker is infinite, right? Tip number 4 is encourage weirdness. If your end users can come up with quirky passwords that are difficult to guess but at the same time are strong, please encourage that. And please adopt stronger policies for your sensitive accounts, right? Your critical accounts, your privileged users cannot use the same password strictness as your domain users, right? And finally, and the most important point is educate your end users, right? Your end users need to know the basics of password security, right? Set up training sessions, set up workshops, make sure your end users know how to treat their passwords with utmost importance, right? Now we do have a tool called the Weak Password Reporter tool that can be used to check the strength of the password hashes, right? So what happens is the tool has its own set of inbuilt weak passwords to which you can add in your own passwords as well, right? So what it does, it obtains the password hashes from the users in your domain environment, right? And it compares the weak password hashes to the actual hashes obtained from Active Directory, right? And if the hashes are found to be matching or weak, this tool prints out a report, right? So using this, you can judge and set a proper password strength for your domain environment, right? And once that's done, let's quickly head into AD Self-Service Plus and implement stronger password policies, right? And by stronger password policies, I mean policies that are in accordance with today's password security requirements, right? So let me quickly open up the browser and let me head into Password Policy Enforcer. Right now, this is the place where you can set up password policy settings that are in accordance with today's sophisticated attacks. Right? For instance, you can set up a minimum password length. Now, this length defines a minimum length that has to be used by your domain users in order to set a password. Right? You can disallow the usage of certain palindrome passwords. Right? You can disallow the usage from previous usernames or previous passwords, right? You can ban the use of certain dictionary words. Now let me quickly show this to you. This is a list of words in the inbuilt dictionary, right? You could add in your own sets of words or specify more dictionaries as well, right? So this would potentially prevent any form of a dictionary attack, right? And we can ban the use of certain patterns. And here we are. We have password at 123 right here, right? Now let me quickly show you something. If I head into my VM here, and this is a user called Pete, right? So let me quickly reset the password for Pete. So once I hit on reset password, let me give in the password. That's password at 123, right? Password at 123. And once I hit OK, we can see that the password for Pete has been changed, but once I enable this setting, right, and once I save it, Active Directory would throw an error, right? Active Directory will not let Pete use these weak password patterns, right? And the password policy can be applied based on the policies configured inside AD Self-Service Plus. Now, please recollect that policies can be applied based on OUs, on groups, and on individual users, right? Now, this policy can be enforced from the ADUC password reset and also from the login screen, right? From the GNAR login screen, right? Now, a quick recap of what we just saw. We saw how easy it is to perform an attack, right? How a user with no privileges can perform an attack, right? And in order to combat that, we set up two-factor authentication at the logon screen. And what happens is this secures access to your on-prem resources, right? And your on-prem applications, right? Now, when it comes to applications that have their own mode of authentication, right, that have non-AD based authentication, we combine two-factor authentication and single sign-on, right? So what happens is the user has to log on just one time and can have seamless access to all of the cloud hosted applications, right? And then I said that password attacks can come in many forms. So a complete fix to this problem is using strong passwords and combine that with two-factor authentication, right? So what we did was we employed strong passwords and combined that with two-factor authentication to ensure complete all-round protection, right? So thank you so much for listening. My name is Abhilash, abhi@manageengine.com. That's my email ID right there. So if you have any questions, just drop me an email and I'll get in touch with you very soon, right? Thank you so much. Have a great day.